Everybody should be taking a seat, please. And I am taking attendance from your phones. So, geometry, B block.
John. Yeah. Hey, John.
Oh my.
3, 4,
Hey,
5.
Elliot. 6 is not here.
What?
So I'm good. Mr. McGowan.
Yeah, on the desk.
On the desk, thank you.
Hey, Elliot.
He's peeking.
Langley.
Elliot.
Elliot. There's Simpsons is right here.
Elliot.
Stangle.
Elliot.
Okay.
Whatever.
My phone is stuck.
Uh-oh.
Oh, my bad.
Now that we have taken attendance, what we're going to be doing is we're going to be taking a look at lesson 13 and lesson 14 today. Everybody should have at some point last night or this morning done your videos, your Ed Puzzle videos. Any questions on those videos so far that we need to address?
No.
Okay. I will make you guys aware that at some point, probably, there's going to be someone coming in and sitting in the back or something like that, just to observe. So just be aware of that. Just because, so if you guys don't know, I'm getting my master's in education, and part of the stuff that I have to do is have someone come in and observe some lessons. So that's what we're going to do today. Someone is probably going to pop in at some point. If she doesn't come in, that's fine, but just know that that may happen at some point during the class period. So what we're going to do first is we're going to take a look at lesson 13 and lesson 14. So if you don't have your notes out, go ahead and pull them out now. I'm going to be standing back here for a lot of the period because I've found that it is easier for me to see up on the board and use my little fancy tool back here that I built to be able to show you guys what I am doing as I'm doing it. So everyone should be focused up on the board, and if it becomes a distraction, me back here, I can always move to the front and see how that goes. I do want to note that I sent out an email to a few of you. So if you could just take a look at your email and then respond to the email so that I know you saw it, and I'm putting a plan in place. All right? Any questions on that? Okay. What's that? Yeah, 13 and 14. 13 and 14. Right? What was lesson 13 on? Those of you that completed the homework. Rotations.
Like we're have to like craft the L or whatever.
Craft the L.
You know, like we're have to cut out the angle.
Cut out the angle. Exactly. How did that process go? It was a little weird.
Yeah.
Okay. It was a little weird. Plainly, how did we look? Okay. All right. Straight edge. Use a straight edge.
I need
Okay. Right here. Okay. Awesome. Did you do the process?
Yes, but I did it on a different.
On a different piece of paper? Okay. How did it go, John?
I actually didn't have my tools, but usually,
Okay.
you know, I'm pretty good with the compass. I just didn't have a compass at home.
Okay. All right. Just make sure that gets done. Okay. Make sure that gets done.
Yeah, I got plenty for the tools.
All right. So with the rotations, what you guys did in along with the videos, you actually cut out that angle, that 75-degree angle, and you rotated that figure at point P. Okay. What you guys have probably seen before is something that looks similar to this right here. Okay. Let me zoom in. What you've probably seen before is something similar to this right here, in which you are rotating on a point that is actually on the figure. Okay, that point P is actually on the figure, and you rotate at that point. What we took a look at on the homework was rotating on a point that is absent from the actual figure. It's off of the figure. So on my work right here, we see point P right here, and we rotate it around that point instead of a point on the figure, like point F, for example. Okay? What we're going to do today is we're going to do a lot more practice with lesson 13, and do a lot more practice with these rotations. So what I want you to do is we're going to take a look at, let's see, we're going to take a look at examples 1 through 3, in which we are going to actually be drawing the, let me take a look. We're going to determine the angle of rotation. So in other words, what you guys are going to need today is you are going to need a protractor. Does everyone have their tools, protractor? Okay, awesome. Thank you, Jack.
I don't have it.
If you don't have your protractor, I have a few up at the front. So John, I would ask you if you could just grab a few of those and pass them out to anybody that needs them.
Is it the half circle thing?
Yes, that's it. Okay. I might not have enough for
Do they have to
everybody.
be like super big, or do they just have to be like any size?
They have to be any size. Any size works. Okay. All right. I may not have enough for everybody, so if you do not have a protractor and I don't have one for you, then what I would ask you to do is to make sure you take a look at your partner, and we'll try to distribute them enough so that everybody has a protractor next to them. Remember, if you do not have these tools, you should be getting them. If you can, if you're having any issues getting those tools, just let me know, and we can try to work around that and figure something out. Okay? Yes?
Do you have an extra copy of like fish?
Yes, I do. Yep. Here's 13. They're right here. And lesson 14. So everybody should be pulling out your protractors. John is passing one out to those that need one.
Why is it so small?
Ryan, do you want one?
Check.
Ryan.
I started doing video with this and this operates this.
All right. Does everyone have one, or at least have one next to them? Yes? No? Maybe so? Who knows? All right. So this is what a protractor looks like right here. Okay. If you got the Amazon thing that I suggested, if you got the Amazon set, which I had listed, then yours is going to look like this. You have all the tools necessary for geometry in your set. If you don't have something like that yet, make sure you get it, because we will be using these tools as we go throughout the semester. All right? What we're going to take a look at on exercises 1 through 3 is actually finding the angle of rotation. What you guys did in the video on Google Classroom through Edpuzzle is you actually used the angle of rotation that they gave you to draw the new figure. Okay? So we have A, B, C, D. That is our original figure, or our pre-image. Okay? This is our pre-image, A, B, C, D. And our image, okay, our image is the figure that we're going to get after we rotate, or after we perform the rigid transformation. Does anybody remember what a rigid transformation is? No? Rigid transformation? No. Okay. This was from lesson 12, and I know we didn't get to that yesterday, but because a lot of this directly relates to lesson 12, we're going to skip over lesson 12 to go over this information, which is directly related to it. All right? So a rigid transformation, what does rigid mean? Let's break down the word. Rigid.
Something that has not a straight line, or not something that's like smooth, that has like bumps.
Okay. All right. Something that's not smooth, that has bumps, Luke says. Does anybody want to tag on to that or adjust that? Jack?
Solid.
Solid. Okay.
You have something that's liquid and rigid. You have something that's
Okay.
gas and
All right.
rigid, so it has to be
Okay.
something.
Something that's not liquid, something that's rigid, it's solid. Okay. Anything else? John, any thoughts? No? Rigid. What is this? This is pretty rigid. It's unmoving. Okay. It's hard to move it. It's pretty rigid. All right. It's something that's stiff. Okay. Stiff. Rigid is stiff. So it's unmoving. Okay. I can't stretch it out. I can't contract it. it's rigid, it's not gonna move, okay? So a rigid transformation is something that it changes basically the location of the original figure. Changes the location of the original figure. But nothing about the figure actually changes. Okay? The figure itself is rigid. If we take a look up here, this original figure and this figure, this image, they are identical. They're exactly the same, only this figure right here has just adjusted its location. Okay? So rigid transformation on lesson 12, if you remember that. If you don't remember that, you can pull out lesson 12 here in a second and take a look. You should have written this down in your notes. Rigid transformation is where you adjust the location of the original figure without actually changing the figure itself. Okay? So all of the distances between, let's say, A and D right here, that distance is going to be exactly the same as the distance between A prime and D prime. Okay? That distance is going to be exactly the same. The angle A prime, D prime, C prime, so this angle right here, that angle, I'll do it in red and bigger, that angle right there is going to be the exact same angle as this. Okay? I'm not changing anything about the problem. I'm not changing anything about the figure. I'm just adjusting the location, and that is a rigid transformation. A rotation is a type of rigid transformation in which we are moving the point or the figure around a certain center point. Okay? So you can think about it as a circle, or you can think about it as a clock. I don't have a clock in the room, but if you were to take a look at a clock, which I'm going to put up on the screen right here, we have to think about the direction that our rotation is going. Okay? Counterclockwise versus clockwise. Do I have any card players in here? Anybody who likes to play cards?
Yeah.
Typically in a card game, you would move in a clockwise direction, all right? That means you're moving around to the left if you're looking at it from a top view. Or if you're looking at it from right here on the clock, you would be moving from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 as you move around, right? Counterclockwise is the opposite direction, moving around the other side. Let me get rid of those points there, right? So you would be moving in the opposite direction. Okay, does that make sense? Counterclockwise versus clockwise. When we are defining a rotation, we have to make sure that we know which direction we are moving. Which direction are we moving? Clockwise or counterclockwise? And then we take a look at the angle at which we are rotating. Okay, the angle at which we're rotating. What we're going to do now is we're going to take a look at how do we measure what that angle is. This is our first time using a protractor in this class. You may have used one before, but what we're going to do is we are going to measure that angle, okay? What we did in the video was we actually took that angle and we drew a line along that angle up to the point that we were looking at. So what we're gonna do now is with my highlighters, because it's easier to see with a highlighter, I am going to draw a couple lines, and I want you to do that with me on exercise 1, which you can find on page 71, S71. And let me get my straight edge out. Okay, if you don't have a straight edge, make your lines as straight as possible and try to get a straight edge for the future. We're going to be using our straight edge to draw corresponding lines. Okay, so starting out with D prime, C prime, I want you to draw a line just like that. D prime to C prime. Okay? I like to do it with highlighters that have colors because it often helps ourselves visualize that information better. It helps it pop out. so that we can see it. So that is going to be super helpful for some of you. Some of us, that doesn't necessarily make a difference in the way that we look at it. But if you have the highlighters, go ahead and pull them out and do that. Okay, everybody got that done? Thumbs up if you've got it. Okay, I see most people have got it done. Okay, perfect. Now what we're gonna do, I drew a line from D prime to C prime, okay? That's the rotation that I did. This dotted figure, that's the rotation that I did. Now what we're going to do is we're going to draw a line along the corresponding side to the pre-image. So draw a line along that image there, okay? Your angle should look very similar to mine, okay? And use your compass, or not your compass, your protractor as you're drawing those lines. Okay, are you drawing your lines?
I did it for this one.
Oh, for this one, I'm sorry, yes.
Or did I do the wrong one?
Okay, nope, you did good, you did good. I was just looking at the wrong one. So D prime and C prime. What I'm gonna suggest is bring it out, since you're using a pen, bring it out further so you know which lines you're working with, okay? It's gonna help as we're looking at using our protractor, okay? All right, has everybody got it?
See.
Perfect, okay? I can pause if anybody needs me to pause, so let me know. All right, now, what we had in the video was we had an actual cutout of the angle. This, I think it was a 75-degree angle, and we had an actual cutout of that. Right here, this is where our cutout would be at this angle, showing us you measured the distance on the pre-image right here, D to C, okay? And then you measured the same distance from D prime to C prime, okay? So you measured the distance between D prime, or D and C, and then you measured the same distance at that angle, D prime to C prime. From there, okay, you're gonna be using your compass to measure that, or your protractor to measure that angle. So what I want you to do is put your protractor up on the board, and you might, like me, have to lengthen out one of your lines to make sure it reaches the top of your protractor. Some of your protractors are clear or see-through, so that doesn't matter as much. But I'm going to increase my line there so I can see it when I put the protractor on top of it. So what I want you to do is there should be a little notch or an empty circle right here on your protractor. Should be a little notch there. That's showing you the very center point, or where your vertex of the angle is going to go, okay? The vertex of the angle is where the two rays, this ray and this ray, is where they meet up right here, okay? So put your notch, or your circle, or whatever it is, on that vertex, and then line up your bottom line with the bottom of your protractor. It should be lined up exactly. Does everybody see that?
Wait, is it?
Okay, so yours, Brandon, you're going to put your vertex right in this point right here. Okay?
This hole right
That hole right there.
I am right.
Right?
I got my hole in mine.
That notch, good Pierre. Okay, so right at
Oh,
that,
yeah.
where that crosses, right there, you're going to line it up with the vertex, and then line this line up with that line on the image. Okay? So yours, you're gonna line it up right there where that line meets, and then line up the bottom with your line on the image, like that. Okay?
Huh?
Good. Yep. So you're just gonna line this up
I'm tired.
exactly so that the center will set.
There's not, and then it's
Each protractor is a little different, guys. If you have one that looks like mine, you're gonna do that exact process. If you have one with a circle in the middle,
I was like,
you're gonna line up your circle like this. Okay? So I'm actually, can I borrow yours for a second?
I did.
Cameron's got one that's similar to a lot of yours.
I did.
Okay?
I didn't get
You getting a different one, Mr. McGowan? Yeah?
That's
I did.
Okay.
It's not a protractor.
So, I'm just gonna use my copy because it's got the color. Okay? If you're looking at Cameron's protractor right here, you're gonna see that he's got a little circle right here. Okay? You're gonna line up that circle with the vertex, and then the line that's drawn on the protractor should be lined up with the line, the bottom line of that angle. Has everybody got that? Everybody's got it? Thumbs up? Okay. All right. Now that you have that, okay, I'll bring Cameron back to his. You're going to see where the other line lines up with one of the angle measurements on your protractor. So, let me line up my protractor again. Okay. My protractor's a little bit different from yours, from some of yours anyway, and it is lining up directly at 105 degrees. Okay, 105 degrees. Now, I want you to take a look at this angle right here and tell me, does that look like 105 degrees?
It's
Right?
the other side.
No.
On mine it says.
It's going to be the other side of it.
Yeah,
On your protractor, some of you have two different numbers. Okay, the two different numbers tell us this information right here. Okay, so I'll do purple. Okay, what the protractor is going to tell us is that if I were to extend this line out, what do you guys see about this line right here?
It's at 180 degrees.
It's 180 degrees, okay? It's 180 degrees. So what the protractor is doing is, on some of yours, the top number, I believe, is going to be the larger number, okay? So you should be measuring about 105 degrees on this angle right here, okay? That's what your protractor is doing. It's measuring this angle, this larger obtuse angle. What does obtuse mean? From elementary school? Greater than 90 degrees. Okay? Greater than 90 degrees. So it is measuring this angle right here. I'll draw it in green. That'll pop out.
105.
It's measuring this angle as 105, which means that this angle right here in orange
Is 75.
is what? 75. Right? So this angle that you have now measured is 75 degrees. It's an acute angle, which means what from elementary school?
It's smaller.
It's small. Okay?
Smaller than 90.
It's smaller than 90 degrees. Okay? It's smaller than 90 degrees. Okay? So that is how our protractor works. Any questions on that? Okay? What I am going to ask you to do now, give me just 1 second. Okay? What I'm going to ask you to do now is I'm going to walk through this problem down here. But I want you guys to give me the directions in how to do that. All right? The first thing, did I lose connection here? No, I didn't. Oh, that's because I did some drawing. Let me get rid of this drawing. Right? So using this problem right here, we are going to figure out what is the angle of rotation. What is the angle of rotation? All right? I want somebody to give me some thoughts on what my first step might be. Who can tell me?
Wouldn't you line up both the D's?
Okay, line up both the D's. Okay, that's what John thinks. Anybody else?
Yeah, line up both the
Line up both the D's. Okay. Anybody else? Okay. what did you do on this problem? Let's take a look at this problem.
Oh, hold up. We lined up both of these.
Let me get this right here. Just a second. Okay. So on this problem right here,
We lined up both F's.
okay, what did we do?
Oh.
Okay, where did we place the vertex of our angle? Where did we place the vertex of our angle?
In the middle.
We cut it out, and we placed the vertex of our angle at what point? Who remembers from the video?
Where's that?
Right at the
This is on the first page of your student
Isn't
packet.
it right at the intersection or like the angle like it's to the left of the 75?
You put the vertex on point P, okay? Because point P is going to be your center of rotation, okay? You put your angle on point P because point P is your center of rotation, okay? So that's exactly what we're going to do. We're going to find the point where the vertex is on point P, okay? And I'm gonna just roughly draw this up here because I don't have it cut out anymore, okay? You put your vertex at point P, you lined it up one side of the angle with a point on the original figure or the pre-image, okay? So you lined up your angle like that, and then you brought your 75-degree angle, right here, this is 75 degrees. You measure this distance right here, right? So from point P to point F, measure that distance, and measure the same distance over here, and you put a point on the line. So who can tell me what I'm going to do
You're gonna draw a line from
with
D
this
to E.
problem? What's that, Luke?
You're gonna draw a line
From
from D to E.
D to E, okay? Exactly what I'm gonna do. And I'm gonna suggest that you draw the line larger so that it reaches where your compass is. So, draw a line from point D. Let's try to zoom in here so you guys can see a little bit better. There we go. Draw a line from point D to point E, and I'm gonna extend it out pretty far so that we can see that angle there. Has everybody got that? Okay, we draw that line between D prime, or D prime in this case, what I did, to E. And then we're gonna draw the angle, or the second ray, meeting at that vertex, all the way up to the pre-image, the corresponding point on the pre-image, which the corresponding point is gonna be my D and my E prime. Those are corresponding points, okay? So, on your papers, draw that line from, E to D. And that is going to be your angle. Okay? Does everybody see that? Lengthening it out as much as possible so that we have a couple angles and things to look at. All right. Now, right? Now, what do we think our rotation is going to look like? Right? Are we working with this larger angle here, or are we working with a smaller angle, like this angle right here? Okay? What do we think? Anybody? Okay. Does it look like it moved super far?
No.
Okay. It didn't move super far. So is our angle going to be huge, or is it going to be smaller? Probably going to be a little bit smaller. Okay. Okay. Could be larger. Okay. Let's take a look here. We're going to identify the direction that it's going and the angle at which it moved. Okay, so let's take a look with our protractor right here. Okay. We're going to take a look at the angle right here from E up until, and I'm going to have to lengthen out my line so that I can see. What you're going to find with this problem, guys, is that you could have a couple different angles depending on which direction you're moving, and I'll go over that in just a second. So go ahead and find your angle real quick. Lengthen out. This angle right here is an acute angle. It's an acute angle, so it's going to be the smaller angle measurement. Okay, so place your notch, line up your lines. Who can tell me what angle we are working with?
We are working with a 130 degree angle.
130 degree angle, okay. I want 130 degree angle right there, okay. But we're working with the smaller angle because it's an acute angle, right? So take a look at your compasses.
So a 50 degree
50 degree angle?
for the smaller one.
And a smaller one? Okay, 50 degree angle, okay.
Which one are we looking for? We're looking for the purple, or what are we doing?
We're looking for the one
Yes.
that has an angle, right?
Yeah, go ahead.
This one.
Okay,
Yeah, so the purple.
so we're looking for the smaller angle because that is an acute angle, and since on my protractor it says 130, that's measuring this angle right here, 130 degrees, which Luke tells me that this is the same thing. I shouldn't draw on my board. This is the same thing as a 50 degree angle in the other direction, right? 50 degree angle in the other direction. In other words, if I were to flip around my compass like this and measure that angle right there, I would come up with a 50 degree angle right there. Okay? That's at the 50 degree mark. Does everybody see that? No, you can't see it.
Yes,
Right there.
Freezing temperature.
Right? It's at the 50 degree mark.
Mine's at like 40 now.
Right here.
I hear someone calling my name.
Okay? Yours may be at the 40 degree mark, and this is the problem with physical manipulation. It's not always super exact. It's not always super exact. So we actually have computers that can help us figure out those angles precisely. And if you've taken a look at Desmos, if you used that application before, we can actually use Desmos to perform some of these calculations. Okay? Yes, John?
If the correct answer on a test is 60 degrees and I put 58, do you care?
I will, as long as it's close on a test or on a quiz, if you put 58 degrees and it's actually 60 degrees, since we're actually using physical manipulation, I will be lenient on that degree difference.
Is it like 5 degrees, or is it like how far is like too far out?
Does your split?
We'll make that determination when the quiz comes, okay? I'll probably end up taking a look at everyone's angle measurements and find a range that I'm comfortable with. Okay? All right, so that is how you find the angle measurement. Now, which direction did we go on this? Okay?
Counterclockwise.
We said this is either a 50 degree angle. John found it to be a 60 degree angle.
No,
Okay.
I didn't. No, I said I found it to be 48. I said 60 as an example.
Okay, you found it to be 48.
Yeah.
I'm sorry. Okay, you found it to be 48. Some of you found it to be 50. That's in the general area, the general angle measurement that we're looking for. So, that's close enough. Which direction did we rotate? Think about clockwise versus counterclockwise. Which direction did we rotate?
Clockwise.
Clockwise. Okay, we went clockwise 48 degrees or 50 degrees, depending on how you measured. Okay? We went clockwise, 50 degrees or 48 degrees.
I thought you were talking about the figure that was given, the rigid one and the non-rigid, that's what I thought you meant.
What's that?
Was the counterclockwise, because I thought you were talking about the two different figures.
There is no such thing as a perfect circle.
Yes, we moved the original, or I'm sorry, you're right. I was looking at it wrong.
Wait, what? No, Jack, there's little hinges on this.
I was looking at it wrong.
So you
Okay?
can't do that.
Jack pointed out a good point. Everybody listen up for just a second. Okay? Is everybody looking?
We got a problem.
Okay, let's look at it.
No, wait, because your line filled it up, while mine went through the dots.
Okay?
Oh, yours is.
Jack, what did you do?
No, mine's lower than yours.
Yeah, mine went through the
Okay.
dots as well, Luke.
Yeah.
What angle measurement? What angle measurement did Brandon come up with?
Like 45.
45 degrees. Okay. So what I would say for you guys, is that anywhere between anywhere between 50 and 60 degrees would be accepted. Because we're working with physical manipulation here, and humans are full of errors, as we know from the beginning of time with the fall of man. All right, we know that humans are imperfect. I'm not looking for perfection. I'm looking for you guys to understand the concepts, because as you move into real life scenarios where you might be using this information, you are going to have checks. You're going to have computer software that is going to do some of these calculations for you. I want you to do your very best to be as precise as possible, but as you can see, my line here is pretty thick. Okay, that adjusts my angle by so much if I don't get it precise. Okay? Yes, Lane?
I just have a question. So, like, with these, like, how would you know if it's 50 or the other ones, right?
So remember, if you're working with an acute angle, which we're working with here, an acute angle is going to be less than 90 degrees.
So it'd be the smaller one.
It'd be the smaller one. If you're working with the bigger angle, it's going to be that distance there. So what I want to ask you guys is, I made a mistake. And Jack pointed out my mistake. Okay? I measured this angle right here, assuming that this was my pre-image and this is my image. Okay? So this is the original figure and this is the after image. Okay? What I actually did was I went this direction, working with this angle right here, which, what is the relationship between this angle and this angle? They're vertical angles. Good. If they're vertical angles, what does that mean about them? They are the same. So that's a 50-degree angle. I just got my direction wrong. Okay? I'm actually moving in this direction 50 degrees. What is that direction? To the left, which is counterclockwise. Okay? Counterclockwise.
He said to the left immediately as you would in the song, which you said to the right.
To the left, to the left, to the left. Everybody move in a line to the left.
So it's not
All right.
clockwise?
So we are moving in a counterclockwise direction because we're going backwards on the clock.
But so when do you walk it by yourself?
What's that?
When do you walk it by yourself in this?
When do I walk it by myself?
Yeah,
Well,
and-
when I'm feeling in the mood and I really want to get a move going here, all right? So, all right, we're moving in a counterclockwise direction 50 degrees. But I can move in the other direction, okay? I can move in the other direction. What if I move in
To the right.
to the right, to the right, to the right, to the right? What if I move in that direction? What did I just create there?
A circle.
I just created a circle, and what's the degree measurement of a circle?
360.
360 degrees. So, I'm moving in this direction, and I cut out this portion, okay, in pink. I cut out this portion of the circle. In other words, which you guys told me was 50 degrees. If the whole angle measurement of a circle is 360 degrees, and I just cut out a 50-degree angle, what do I have left?
Two, no, three,
Not quite.
three, 10.
310 degrees.
John.
So I have two different angle measurements.
Threw me off.
I have two different angle measurements. Listen up. I have two different angle measurements, 50 degrees and 310 degrees, depending on which direction that I'm moving. Right? So I moved around this way in a clockwise direction from point C all the way over here to point C. Okay? That was 310 degrees. If I move counterclockwise, I'm moving 50 degrees. So it is very important when you are defining these movements, these rigid motions, you define which direction the rotation is going. Okay? If I say I move in a clockwise direction 50 degrees, you end up with the issue that I presented to you guys, on purpose of course. All right? On purpose of course, you would end up with a figure over here somewhere, 50 degrees in a clockwise direction. You have to be precise in your descriptions. You're moving in a counterclockwise direction, 50 degrees, rotating around the point E. Okay? From there, you're going to move in a, you can say that I'm also moving in a clockwise direction around point E at 310 degrees. Does that make sense? Nickels and pennies?
Nickels and dimes.
Nickels and dimes. All right. So what I'm going to ask you guys to do now is we're going to take a look at M. Okay. We're going to take a look at M. Wait, I'm sorry. Nope. Go back to the problem set. What we're going to do is I'm going to have you actually work on exercise 4. Okay? Go to exercise 4, which is on page 73. And I want you to work with a partner to see if there's a way that you can find the point of rotation. So this time we don't have the point of rotation. What we have to do is we have to use our protractor. Okay, for the center of rotation, we have to use our protractor to find where is my point of rotation. Okay, I'm going to give you a hint. You may have to use a compass. All right, so I want you to do that problem with a partner. I want you to try to see if you can find that point of rotation. You're going to be moving backwards in some cases from the concepts that we've talked about. And I want you to give it a shot, right? I want you to use the knowledge that we've gone over so far to work with your partner to go over that problem. Here in just a minute, we will take a break and then go over lesson 14, okay? Go. Work with your partner. I want to hear geometry talk.
I don't know what I made, but this is so cool looking.
Oh, Jack.
No, but sure.
Oh, 9.
All right.
I don't know about you. Here, do you do that?
Okay.
I'm trying to find the center.
So my suggestion is where's your compass? You're actually drawing circles. Remember, guys, that you are going to be using your compass on this. So I suggest getting out your compass. Try to manipulate your compass in a way that you can find a point of rotation. Okay. Awesome. You're gonna have to put your pencil in that one.
It's usually small one, right?
Nope, you can use this one. Use this one. You actually Put your pencil
You're
right in here.
listening. Here. Here's the No, no, no.
Now, what I want you to do is
You
you're
don't-
gonna lengthen this out to the distance between the corresponding
Here, check.
points.
Two prime.
And F prime. Okay? So F
This is the same
and
as
F
that.
prime. You see that?
Yeah.
Okay. So what we are going to do actually is let's use our straight edge.
You did? No. That was bad.
Yeah. Sounds better.
Or you could do something.
At least 5.
Now that I have that segment,
Here, you're gonna
I'm going to find the perpendicular.
I just noticed running you can just look at it, it's like, you know, if you move it like that, it's like, this one is that these ones are so simple to make. Once you accomplish it, it's gonna be good.
Don't they have to be like,
like one. One.
with the intersecting point there?
Oh, wait, I did. I'm going to draw our two arcs here on that movie. Come over here.
Sorry.
This way. And draw my two arcs. Check your shoe.
Are you a house here?
And I'm gonna have to redo this. I'm on trust.
Oh, that's why you have to.
Now, from those intersecting
What are they trying to
points,
get you to do?
Run
Dad?
with. You gotta go. You gotta go.
Fine.
I'm gonna draw a line into
Here.
lunch.
Here, I want to
Straight
look. I
line.
want you to
Straight line into
like,
Fine.
come on.
Right?
I will.
I'm gonna just force you to go.
Hey, how's everybody doing?
Good.
Good? Do we think that we have it?
No. I'm so
No?
confused.
Not
Yeah.
as easy as the other one.
Okay. We'll take a look at it, no worries.
I'm just having fun.
What is it?
Last time I called math fun was like first grade.
Right.
I can barely.
Now that we have that perpendicular bicycle,
You better go.
So you just.
I'm gonna suggest
I didn't
we
even
do
know what
this.
the word
I'm
meant.
going to draw
I didn't read it. I remember I got in trouble for copying.
between this point right here
What first
and
grade?
different points on the figures. So I'm gonna draw.
I just said,
How did it work out?
I had to take the walker. So did you
No,
get
I
it?
asked you.
It's
It's done.
I didn't know what it was.
Camera.
I just put my finger on it.
There.
You shot pointed it
Triangle,
out.
triangle.
Make it triangle kind
Email the,
Yeah.
To like review with me.
Girl, I'm the reason he's
of,
on.
right?
I don't, I mean.
That triangle right there. What I'm gonna do is I'm gonna measure that angle.
Wait, what am I looking for?
And I'm gonna see if that angle is the same as the distance.
Yeah, no, I just.
extension, I do, yeah.
This angle.
You never do, this is actually like pretty simple, you really need to start trying.
You got it, John?
Yeah. What? This is, yeah, this is pretty simple.
What, I tried to.
Okay, this problem is insane.
I'm pretty sure I can hear this pencil now.
No, I have.
I was just.
So, I'll, now go up to the board, and I'll do it up on the board. John, you think you've got it?
No, I understand the first one.
Don't look at mine because I kinda guessed.
No, what always happens is they'll do the practice problems and I understand them, but then the other ones will be like a curveball. There's something small about it that's different. It's like, on the other ones, you can see this point of rotation, now we can't. So, I don't understand it, but like, I understood the first one really well.
You understand the first one pretty well?
This is what always happens in these practices, is you'll do a practice problem, and then the next one that we do is a curveball that you don't understand.
That's okay.
This is very.
That's okay.
Yeah, I did.
So, what I'm actually going to do now is we're gonna watch a tiny little video
Thank you, Lou.
on how to find the center of rotation.
You want a minute?
Oh,
If it's just on the floor.
so?
You don't really stay, this is for you.
You can
My
eat it.
present.
You wanna see my paper and do this? Oh, this thing doesn't even work, I just have to try.
They mix
Yeah, seriously, you can't fit a pencil in
Wait,
there.
what?
I'm not gonna let you do that. That sounds
All right.
way too minty.
It used to be smooth.
So-
My brain would just not know what to do.
Okay, so I want everybody to pay attention to this video. Who is going to go over this problem with us, and then we're gonna perform the same rigid transformation or find the same center of rotation. So, pay attention to the video.
Provide this supplementary material. The course is taught in how to calculation. And in this video, I'm
You
going
guys
to
will
show
recognize
how to
this guy
find the
because he's
center
going to be
of
part of your
rotation
homework tonight.
And the angle of rotation. So I've got this orange quadrille, and I've labeled it A, B, C, D. And its image has been rotated through some angle over to the green quadrilateral is. I've labeled that A prime, B prime, C prime, and D prime, so we can see the corresponding angles. The first step in finding the center of rotation is going to be to connect two pairs of corresponding points with a straight edge. So I'm going to connect point A and point A prime.
I saw a lot of you doing this. Good
And then
job.
also connect point B and point B prime. And now what I want to do is use a compass to find the perpendicular bisector for each of those lines that I've just drawn. So I'll place the compass point at point A.
Listen up, guys. Listen up. Just watch. Just watch, Mr. McNally. Thank you.
Place it at point A prime. And draw two more arcs that intersect the first ones I've drawn. And I'll switch to a black marker so we can see what I've got. I'm going to connect those points of intersection. And the line that I get is a perpendicular bisector for line segment A and A prime. And now I'm going to do the same process on the other lines of B, B prime. So I'll place the compass points at B prime. And once again, draw some arcs. And then move the compass point to B. Intersect those arcs with two more arcs. And I'll take the places where those arcs intersected. Connect them.
So,
And now I've got a second perpendicular bisector. That's the perpendicular bisector to
perpendicular bisectors, what does that mean?
They're perpendicular.
They're perpendicular and
Oh,
bisect.
It
Oh,
goes
oh,
in the
they
middle.
split
It's
even.
Splits the segment in the middle.
Equally.
Equally.
Yeah.
Okay. So he found the perpendicular bisector of this segment between B prime and B and A prime and A. Found the perpendicular bisector of both of those segments. And at that point,
line or line segment, B, B prime.
he's going to show you.
And the place where those two bisectors intersect each other is the center of rotation.
Center of rotation.
Okay? So once again, what I
Okay? So, I want everybody now to find the center of rotation for that example. Alright? If you need to, you can go to number 5, exercise number 5. If you made a lot of lines on the first one, you can go to exercise 5 and actually do that on that problem. So, save that for later. Alright? So, on your problem, do this with me. Do this with me. I'll just go to number 5 since some of you already have a lot of lines. I'm going to use my straight edge to draw the line between C and C prime. C and C prime. Oops. Didn't quite get all the way there.
Can we draw through the figures? Like, if it's on the other side of the figure and I want to connect B to B, can I go?
Yes, you can draw through the figure.
In my case.
Okay? Draw that line B to B prime, exactly like that. Now you're going to take out your compass and you are going to draw the perpendicular bisectors of those two lines, and where they intersect will be your point or your center of rotation. So set your distance, the distance between C and C prime. Okay, draw your two arcs, top and bottom of that line from C prime. I'm going to now go over to C and draw those two arcs there. Those intersections are going to be my perpendicular bisector. Now I'm going to find the perpendicular bisector of the other problem. So lengthen out your compass to the distance between B and B prime. B and B prime. Draw your arcs. Go over to B, put your point on B, and draw those arcs. And then draw your line between them. Everybody's got it? Where those two lines intersect, is going to be your point or your center of rotation. In orange, that point right there is your center of rotation.
Wait, how do you get the one all the way down there?
Which one?
The one, yeah, right there.
This one?
Yeah.
So you drew your, you found the distance between B and B prime, and then putting your compass's point on B, you came down here and you drew a couple arcs here and up here.
Okay.
And then put your point on B prime and draw an arc down here and down here. Those circles will intersect and you draw the line in between those
So you have one
intersections.
at B and B prime.
Exactly, right? Now that you have drawn the intersection of those perpendicular bisectors, that is going to be your point
You're gonna have that.
of rotation,
You're gonna have that.
right?
Does that look even right there? No, I don't think so.
Between C, yeah, so you drew the intersection or the perpendicular bisector between C and C prime. That does look correct.
How do you know,
Yep, good. Draw the intersection between those lines and you find your point of rotation.
so how do you know which line's supposed to, like, connect at the start?
Oh, I see it now. Okay, so you just.
So you know, that's a good question. John asked us a question, how do you know what points to connect? Well, they call this B and B prime for a reason. B corresponds with B prime. This is the same point on this transformation, okay? Remember that a rigid transformation does not change the figure at all. It does not change the figure at all. It instead just moves its location. So B is the same point B prime on this figure. So you're gonna create your original lines in purple between B and B prime.
But it doesn't really explain it though, because why wouldn't you just do D and D, D prime and D?
So you can do
that's
D
one-
and D prime.
So you can do any of them. as long
Absolutely.
as I see.
If you do D and D prime, if I were to draw D and D prime, we're running a little low on time here. We're probably not gonna get to lesson 14, but that's okay. If I were to draw the line between D and D prime,
Like you're just huffing your own breath.
I have breath.
with my purple, John, you asked a question, so make sure you're paying attention. Everybody else respect that as well. All right, I drew the purple line between D and D prime. Does everybody see that?
Mm-hmm.
Okay.
Yeah.
Now I'm going to find the perpendicular bisector of that distance. So lengthen out your compass to the point between D and D prime. Okay, and I want you to find. I'll show you the marks that I made in just a second. There you go. So I made this mark right here and this mark right here, putting my point on point D, just like this. Okay? So make that arc right there, make this arc down here. Now put your point on D prime and make two arcs in the same direction. Now draw the line in green between those 2 points.
Can we make a star? It looks like it might.
Okay?
Well, it won't be perfect.
And you should see
You're not perfect.
that it is going through that same point
Boom. Yeah, it is.
of rotation, that same center of rotation.
Is it really?
It is. It goes directly through it.
No, is it a perfect star?
If you
I don't
extended
think it is a
the
perfect
D to
star.
D prime, the
I don't
E to
think
B prime.
It is a star though, yeah.
I don't know, you guys can figure that out on your own time. But that is how you find the center of rotation, alright?
You know, like.
Any questions on this information? Any questions on this information? Okay? It is 10:10. I was expecting to get through a little bit more time, but that's okay. What I'm gonna suggest that you guys do now, we have 5 minutes left of class. I want you to find the center of rotation for this example 3 on page 72. You're going to find the center of rotation, and if you get to it, alright, if you find the center of rotation quickly, I want you to tell me what angle was it rotated at? What angle was it rotated at? Does everyone understand? Okay, so first thing that you're gonna do is you're going to find the center of rotation of this figure here, and then you are going to find the angle of rotation. Find the center of rotation, and then find the angle of rotation. With angle of rotation, make sure you tell me where it's going. Is it clockwise or a counterclockwise rotation? Does that make sense? Alright, I will be around to help as needed. We have about 5 minutes left in class, and then we can get going.
Can I use a right?
Yes, go ahead. Good job, Brandon. Okay, good job, Alex. Good, okay, you draw a circle now, good. Alright. How are we looking, guys? Good. Awesome. Good, so you drew the segments between B prime and D, and A prime, now you're going to find perpendicular bisectors. Good job, John. How are we doing, Mr. Stangle? Good. Okay, so good, A to A prime, B prime to B, and now what are you gonna do? Okay, mark them. Okay. Good.
Yeah.
And then now that you've got A to A and B to B, yes, you're gonna connect you found the perpendicular bisector to the side. So connect that point to that point.
So Cheryl,
Yes.
is this the perpendicular bisector? Or is that wrong?
Show me.
I know I didn't do it the correct way, but that's.
So show me which line?
I don't really know,
You know what?
Which line are
Yeah, I
you
don't
finding the
wanna hear it.
perpendicular bisector?
A through B, A through A.
Alright, we got
So
it.
is that,
We
And
got
then
it.
how did you find your perpendicular bisector?
I didn't do it the right way, but like, if I did that with all my correct tools, would that have been the perpendicular bisector?
Oh, I knew this.
I'll have to look at my notes.
But does it seem-
Do you not? Oh, you don't have.
Yeah,
Here,
that's the
why
problem.
don't you
This thing
use
was
mine?
trying to hold pencils.
Why don't you use mine?
Super thin.
Whole pencil's gone. Use mine and then I'll be able to assess
Okay.
what we're looking at, okay? There you go.
Okay.
No. That's what I said.
Okay. So,
Okay.
see how that line curves around a little bit? We just wanna make sure we're being as exact as possible, okay? Yeah, that's fine, that's fine. If you have a straight edge, you could always use, like if you pull off a piece of paper over here, you can line it up with a piece of paper and your paper can be a straight edge, okay? So you could always do that.
I actually forgot what to do.
In the meantime, I'm gonna get you my ruler, Jack, so that you can use that to draw the line between. Right? So actually draw the line between that. Right there. Remember, we're drawing from intersections of the circle to intersection of the circle.
I don't know what you mean.
Good. Right? And you draw from intersection of this circle to the intersection down here. Okay? rotation. Good. Good job, Jack. Okay. How did we look?
I think
Got it?
I have like the concept.
Okay. Great.
I just struggle with like the confidence
Okay.
thing.
Sure.
So.
Sure. I understand
But I
that.
get like
And I'm actually, at some point, you can actually walk through this with Mrs. Woods, through this problem specifically if you wanted to. You can actually use Desmos
Yeah,
to
Desmos
perform
would
some of
probably
this stuff.
be-
Yeah. So I'm gonna suggest, and I can send a video to Mrs. Woods if she needs it, but you can actually do this process on Desmos, and I can show her how to do it.
Thank you.
Yeah. Yes.
Great.
They will be up soon. They will be up soon. Yes. Remember to check your emails, guys. If you do not have your emails, I have. Wait, are you guys grabbing those?
Yeah.
I think those are. Yes. Good. Thank you to whoever put those out.
Mr. Sheridan,
Yes.
16 and 15 tonight or just 16?
You're going to be doing 16 and 17
Oh yeah, we're
tonight.
not 18.
16 and 17. We're skipping 15.
What's the?
Yes, 18 as well.
All three? So
All three.
Only 16
Okay.
posted right now.
Only 16 posted?
Yeah.
Okay, I will fix that on RenWeb. It should have been like that.
16 posted and missing 17.
We're not doing that yet, we're skipping it.
Okay, I will fix that. I'll get that up so that it's up there. Right? So, thanks guys. Make sure you grab those. Thank you to whoever put them out.
How long are the videos?
They're like a couple minutes each video. And then there's gonna be like 4 or 5 videos, something like that. So altogether the videos themselves are going to be like, what's that? Yeah, altogether the videos, if you watch them just all the way through, they're gonna be about 10 minutes. But there's gonna be activities you're gonna be doing that's gonna take a little bit longer, okay? All right, thanks guys for coming.
So, 4 or 5.